Any are joining now. Yes. Yes. Let me share the screen of Tinkercad. So if any new join is means I give a introduction about the tool in short one more time. Okay. So in this online session, we are going to use the cloud-based software name called Tinkercad. How to access the tool is very simple. Go to Google browser, type Tinkercad, and then use login option. Using login option, you can make use of your own Gmail ID, personal mail ID to log in this tool. Any newcomers join today means please finish this login process. I repeat once again, type Tinkercad in the browser, okay, followed by click login. The moment you click login, it will ask for the email ID credential. Already I logged in using my Gmail ID. You try to log in using your own Gmail ID, please. Please do it. Any newcomers means finish the task first. Any newcomers today? Oh, many of them did their homework, sir. Good. Varsha did, yes. Ah, Vaishnavi measured the today's task. Very good. We plan to teach this concept today. Good, you did that. You will teach that concept today. Okay. ஒரு பானை சோற்றுக்கு இப்ப 2 சோறு பதம். Good. Two people did. Others no issues. Today try to do it. Um, any newcomers means go to your Google browser, type Tinkercad, using your Gmail ID, login. Please do it. Any newcomers, please type your name or I joined today like that. Please acknowledge in the chat. Let me know how many newcomers are joined today. Any newcomers means yes. Kishore did something good. Kishore mentioned so many things. Today, Sweta, you do one thing. Go to Tinkercad. I shared one link in the chat. Click the link. Okay. Click the link and join using your Gmail ID. Try to do it, Sweta, please. Any newcomers? Any newcomers? Last 2 days class. No issue, Deepak. Deepak, I shared one link in the chat. Click the link using your Gmail ID login. Today I made the recording. We will share the recording of today's class for the any absentees means we will share that also, that will no issue. Wheatstone bridge, but there is no galvanometer. Yes, Potheswaran, no galvanometer. You need to make use of a voltmeter. Okay, I will teach you if you want the Wheatstone bridge means I will teach you. Don't worry. Instead of galvanometer, you put a voltmeter. That's all. Take a multimeter, choose it in the voltmeter mode. So I hope Sweta and Deepak alone is a newcomer, not more than that. If those two people are logged in, means we will start our today's class. Sweta, have you done the login process? Sweta and Deepak. I repeat once again. Go to browser, any one browser. Type Tinkercad. Tinkercad. Otherwise, in the chat we shared the link. Take the particular link, click it. Using your Gmail ID, personal Gmail ID, do login. That's all. Have you done up to that? I hope everyone. I'm also newcomer. Yes, no problem. For a newcomer only, we are waiting. Take a link. Take a link of Sundar today joining. No issues. Sundar Rajan. Take a link shared in the chat. Okay, or else straight away go to browser and type Tinkercad. Click the particular link using your Gmail personal Gmail ID credential login. That's all. Ashwant, no issue. Click the link and join. If you people acknowledge, we will start our today's session. If you logged in, very good, Ashwant. Others, other newcomers, please respond. I have a syllabus question. Sir, I have out of syllabus question. If I ask, out of syllabus question means you wait at the end of the session. You ask. I don't know what question you will ask in the public forum. Wait for some time. Sure. Okay, logged in, done. Okay, good. Jay Akash, you too done, no? Okay. For my old friends, for our new joinees, I am taking a first page and I am teaching the content one more time. Don't fed up with that. Okay. New joinees, sir, is it Tinkercad screen is visible, sir? Tinkercad screen visible, no? Okay, I am going to turn off my camera for the bandwidth utilization. Yes, I hope my Tinkercad screen is visible. A new joinees, please listen. It's a very useful software to do 3 tasks. One is a 3D design. The second one is a circuit. The third one is a code blocks. Okay. What we are going to do in the 10 days training program, that is yesterday one class over, 9 more days we are going to learn. We are going to make use of the second option, circuits. Please note down, newcomers, click create followed by click circuits. I hope you are clear with this. Click create followed by circuits. Okay. If you click a circuit, you will get a fresh worksheet like this. Like this, you will get a fresh worksheet. This is the work plane where we are going to keep our own circuit diagrams and we are going to make a connections and we are going to simulate it. Okay. For a simple recap, what we are going to do is we are going to take one battery. The right hand side, you have a component list. Under the component list, we have so many components. So what we are going to do is to make a familiar about this tool, how to use the tool, we are going to teach with the help of a small circuit what we learned yesterday. Okay. Now I am going to take one 9-volt battery. 9-volt battery. How to take a battery is very simple. Any component you want to take it in your workspace means make a left click and then keep on pressing in the left click and drag the component, place it in the workplace. I repeat once again, any new component you want means make a left click, keep on pressing the left click and drag the mouse slowly and leave it in the workspace. Is it clear? Newcomers, is it clear? Very simple. For whenever we are teaching, you listen the class. After some time, we will give a time to do the hands-on session. Okay. Please listen. Don't do parallelly. If you do parallelly, you will skip some content. Okay. Now I have a 2 battery in my hand. I want only one battery. One more battery I don't want in this workspace means here you have a delete button. The moment you click delete, it will disappear. Is it clear? I repeat once again, any component you don't want means select the component, click the delete icon, or otherwise simply in your keyboard you will find the button called delete. The moment you click the delete button, it will disappear. Okay, is it clear? Then any project if we are doing, it is like our class notes. Whenever we are start writing the class notes, we will put the date and then we will put the title of the subject what we are learning and then the topic and then the content like that. Whenever you are doing any project, make your own project title. By default, the software will give some random name. That random names are we can't remember those names. So better you change the project name. How to change the name? Very simple. Click this box. The moment you click, you will get a cursor over there. Give a backspace button. Delete everything. What I am going to do? I am going to give C30. C30. Okay. C30. Day 2. Yesterday I put as a day 1 class. Today I am going to put as a day 2 class. That's all. So in this way, we can give the name of the project. Okay. I hope this flow is understandable to the new joinees. Now I am going to take on battery. I want to rotate the battery. For that we have option over here. If you press this icon, your battery will start rotate. Your battery will start rotate. This is one option, or otherwise, see here, the R shortcut button is given. If you type R in the keyboard also, the battery will rotate. Is it clear now? Yes. Now what we are going to do is, we are going to expand this component list to get a few more components. Here in the component list, by default, it is in the basic. If you click all, you will get a additional components in the workspace. What we are going to do is, we are going to take this light bulb. I'm going to connect this bulb straight away to the battery. Now the lamp is not glowing. Why this is not glowing is that this is a simulation software. After making the connection, it is like your C program. After writing a C program, you need to run the code. Then only the line one by one line will start execute. In the same way, this also kind of a software simulation only. All this battery and the lamp has a inbuilt program in it. Okay. Now I need to run this program. How I can run? Here, the right hand side, you will find the start simulation option. Newcomer, please note down this. The right hand side menu, you will find start or stop simulation. It is a play button. Okay. The shortcut key for the play button is space bar. If you press a space bar in your keyboard, your simulation will get start. Now I am going to click the start simulation. The lamp is glowing. Is it clear? Is it clear? Yesterday we did use this incandescent lamp. Now I request everyone to do this task and post it in the group, please. Take 1 minute time and finish it. Somebody did a Wheatstone bridge. Pothishwaran, wait. If time permits, I will unmute you in between the session. You can explain the circuit what you have did. Very good, Pothishwaran. Now only I came. Explain once more, sir. Bala Sujay, are you joining today or yesterday you joined engineer? Bala Sujay, is the day 1 for you or already yesterday you attended the class? Bala Sujay, Kanab, please respond. Yes, sir means, are you attended yesterday's class? Please type I attended yesterday's class. Bala Sujay. Sir, how to turn the, what is your question? How to turn the battery down to up? Kana, you press rotate button. See here. Here you will find one rotate icon now. Select the particular component and press this rotate button. It will start rotate. Or otherwise, press R in the keyboard. Do it. Sir, the Bala Sujay asked some question in between their started posting. Bala Sujay, are you attending? You were absent yesterday. Okay, Bala Sujay, you do one thing. I am sharing one link in the chat. Please click the link. Please click the link using Gmail ID. Please log in that Bala Sujay. Sir, we can wait for 5 more minutes, I think. Newcomers are coming. Kavya also new. I am also absent, sir, yesterday. Okay, absentees, you don't worry. Absentees, you don't worry. We shared one link in the chat. Okay. Click that link. Click that link. I am also. Sir, என்ன பண்றது? Sir. See, absentees, don't worry. Don't worry. You click the link, Tinkercad link, what I have shared in the chat. Using your Gmail ID, do login. Okay, cool absentees. I am also newcomer, but I didn't attend the last 2 classes. Hey, cool. I shared one Tinkercad link. Okay, click the link and then join using your Gmail ID. Please do that procedure. All latecomers join. Someone raised their hand. I don't know what for. Any doubt from your side, Dharani Dharan Sivabalaji? Dharani Dharan Sivabalaji? Any doubt? People raise your hand. Hello. Sir, I hope no doubt. Okay, please drop your hand. By seeing your raised hand signal, we are getting confused. How to on the light? Kind of very simple. Very simple. I will do one more time. I will do one more time. I am going to take the battery. I am going to take the 9-volt battery. Click, left click, keep on click and move. Drag the component, keep it in the workspace. Press R button to rotate the battery to your own required orientation. Followed by take the lamp from the component window. Connect the lamp straight away to the battery. Followed by start simulate. Is it clear, engineer? Someone asked the question how to turn on the lamp. Is it clear? Good. So, yes, very good, very good. Sir, I am open, sir. What? Good. Bala Sujay, have you learned how to open the account? Bala Sujay? Yes, sir, done. If you done means you share the output. Until you people finishing the task, I repeat the task again, don't worry. Because many newcomers came. So I repeat once again, see here. So go to Tinkercad, click create. Under the create option, click circuits. I think I can take a screenshot of this option and put it in the chat too. So whoever joining as a newcomer, they can check this. Sir, if any newcomer comes means please highlight it, sir. That screenshot I shared, okay? Cool, sir. If you click a circuits, you will get a fresh sheet. Under the fresh sheet, take one battery, one lamp. That's all. Take one battery, left click and drag, then rotate, then take the lamp. Maybe for yesterday's attendees, this may be a boring one. Please forgive us. All are need to travel in the same path. That's why I'm doing this. That's all. I hope this is clear to everyone. Yes, good. Now, our practical scenario is not like this. We won't connect any load permanently with our system. We will use something to control its light intensity. What type of control we will use practically? Can you type it in the chat? There is no create option. Who's that? Shalini. Shalini, you see once again. Shalini, please see once again. If you get into the Tinkercad tool, you will get an option like this. In the right hand side, nearby your photo, you will take the plus icon. That plus icon is nothing but a create. Can you share your own home screen? We will guide you what to do. Someone asked, what is that? Who's that? Shalini, have you find the create option? Just log in Kanna. Yes. Shalini, have you find the create button? Yes. Okay, sir, you reply for her. Okay. Let me. Yes. As your friend said, we need a on-off control. On-off control. For that on-off control purpose, we are going to introduce this slide switch today. What is the slide switch? How it works? Okay, it's very simple. Let me teach the functionality as well as the output of the switch. Then I will teach its theory part, how it works. Okay. Everyone, please listen. Please listen. We will give a time to do your own hands-on sessions until stop your own works and observe this Tinkercad screen. My humble request, don't do parallelly. We will definitely will give a time. Yesterday attendees very well know. We will give you time to do individual tasks. So cool, take one battery, rotate the battery, and then take lamp. As we thought yesterday, if you want a duplicate component, you can simply select, then Control C, Control V. If you give, you will get a same component as a duplicate. Is it clear? I repeat once again, any component, if you want to take a duplicate means select the component, then press Control C, Control V. Now I made the duplicate of slide switch. See, wherever I click Control V, I will get a slide switch. Okay. So now I don't want these switches means please click undo option. Undo or Control Z. The one by one it will disappear. Is it clear? If you want to redo, bring back the component again means plus Control Y. You will get it back. Please try to explore this kind of shortcut keys. It will be very useful. Now what we are going to do is we are going to connect this 9-volt battery with the lamp using the switch control. For the switch control, so yesterday we made only the straightaway connections we did. Today we are going to teach what is circuit diagram and how to draw that. Okay. The circuit diagram is nothing but a standard symbols we need to use for all these components. Here I have an 9-volt battery. Here I have a slide switch and one incandescent lamp. For all these three, we have a dedicated symbol. You may study it in your school days. So I am going to teach the circuit diagram today. It's not a very new one to you people. Okay. So I am using the paint tool. I am going to teach the same. I hope now I am going to share my paint window. Please ensure once the paint window is visible to you people. Is it visible, engineer? Is it my paint screen is visible? I think yes. Am I correct? Yes, sir. Yes. Now we are going to learn the how to draw the circuit diagram. So as just now I explained, circuit diagrams, we need to use the standard symbols. So here I am going to use some standard symbols. See here, I am drawing one symbol. Can anyone name the symbol what I have drawn? Can you name the symbol, please? Can you name the symbol? Sir, if they typed means, please tell me, sir. What is the name of the symbol I have drawn in the paint? Cell or battery? Engineers, whether it is a cell, okay. If this is, okay, let me draw one more diagram. Please tell me what is this? Please tell me what is this? What is the difference between the first diagram and the second diagram? Please tell me what is the first one, what is the second one? This is first diagram, this second diagram. What is the difference between these two? Second one is the battery. Very good. Second one is the battery. 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 This is battery. What about the first one? What about the first one? Cell. Please take down the symbol, engineers. Please take down the symbol. This is the symbol of cell. In addition to the symbol, we can mark the polarities. The lengthier plate is positive, the shorter plate is the negative. And what is the definition for cell and battery? Cell means, very good. The group of cell is battery. The combination of your cells. It may be connected in series connection or the parallel connection. So here I am having more than one cell in this symbol. Therefore, this is called as a battery. Now you tell me, in our Tinkercad, we are using this fellow, one box like this, and I am having two terminal. What is the name of this fellow? Whether it is a cell or battery, any idea? Whether it is a cell or battery? Battery, very good. Battery mean what is the voltage printed over this? What is the voltage printed over this? 9 volt. Very good. 9 volt. So it is a 9 volt battery. It's a 9 volt battery. For a typical cell, the voltage level is 1.5 volt. 1.5 volt. Please note down this. The typical cell voltage is 1.5 volt. Now you tell me, the 9 volt battery, how many cells are present? Please give your answer, engineer. Please give your answer. The 9 volt battery, how many cells are present? 6. How 6? How 6? How you are telling the 6 is 6? Very good. How 6? 6 is the right answer. How you got the 6? So 9 divided by 1.5 is a 6. What is the meaning? What is the meaning of this? This particular 9 volt battery has 6 cells inside it. How many cells we have? 6 cells inside it. That means, see, one positive plate, one negative plate is a one cell. Then another positive plate, another negative. Then another positive, another negative. Likewise, we have 6 cells inside the package. The outer terminal are connected with the top positive plate and the bottom negative plate. I hope this is clear to everyone. The inside the 9 volt battery, we have 6 cells inside. The top positive plate is taken as a positive terminal. The bottom negative cell is taken as a negative terminal. Remaining all are connected in series. What connection we used? Series connection. Yesterday we learned if you are connecting two resistors are in series, what is the R equivalent value? R1 plus R2. R1 plus R2. In the same way, if you are connecting your cells in series in a proper way means positive to negative, negative to positive like this, positive, negative, then this negative to the another positive, then negative, this negative to another positive. Like that, if you connect it properly, you can add the individual cell voltages. Here I connected 3 cells. Can anyone tell me what is the voltage across these two terminals we will get? Please type it in the chat. I connected 3 cells in series. What is the total voltage of this terminal? Any guess? Please calculate and tell. What is the voltage across this terminal? Individual typical cell is 1.5. 1.5. Sir, anyone answered, sir? 1.5. 3 cells are connected in series. 4.5. Very good. 1.5 plus 1.5 plus 1.5. I repeat once again. Series connection. If you properly connect the positive negative plates together, we can add the voltage of the individual cells like a series resistors R1 plus R2. Okay. Please note down this concept. Let me give 1 minute time to take the notes of this. Please take down this. Please take down this image. Please take down this image. Cells in series connection. You put average cell ampere. Ampere we will teach you. Don't worry. Engineer, please wait. We are talking about only the voltage. Average ampere and all we will teach you. Wait. Because that and all little advanced content. Others may feel a little hard. To keep your question in your notebook, we will teach you what about the current. So what we learned today is symbol. What is symbol? The symbolic representation of the actual component. What is symbol? The symbolic representation of the actual component. Example, what is the name of the symbol I am drawing right now? What is the name of the symbol I am drawing right now? What is the first symbol I have drawn? Any idea? What is the second symbol I am drawing? What is the third one I am drawing? Please type it in the chat. These things are familiar to you people. Already you may study these symbols in your school days. What is the name of the first symbol? Second symbol? Diode. Very good. Then name this coil. Very good. Coil or the inductor. What is the last symbol I have drawn? What is the last symbol? Capacitor. Good. So these are all the examples of the symbolic representation. These are all the examples of the symbolic representation. So whenever we are drawing the circuit diagram, we need to make use of the standard symbols. Okay. Now what I am going to do is we are going to draw the today's task circuit diagram. Okay. Let me draw the circuit diagram. Then you tell me what are the arrangement I made it in the circuit diagram. And then please help me to connect all these things together. I am going to draw 3 symbols over here in 3 different orientations. Can you name these 3 symbols? What are all the 3 symbols I have drawn? What is the first one at the left hand side? Yes, good. It is a battery. What is the second one at the middle? What is the second one in the middle? Any answer, sir? What is the second one in the middle? Switch. Very good. This is switch. Very good. What about the third one at the right? What about the third one at the right? Bulb. Very good. So now you can recollect the Tinkercad. We took 3 components. One is the battery. Next one is the switch. The third one we got the lamp. Now anyone help me how to make a closed path of all these 3 elements. How can make the closed path for this? What element I need to use to make the connections? How I can connect battery and switch together? Any idea? Shall I put any pipe connection for this? Is it via pipe the electron will flow? What we need to connect between these two? What we need to interconnect the 2 electrical elements? Any guess? What we need? We need some wire. Very good. We need a wires. So I'm going to take the red color wire. I'm going to connect it at the one end of the positive terminal to the switch. Clear? Now you tell me The other end of the switch where I need to connect. Please help me. Other end of the switch where I need to connect. Other end of the switch where I want to. One end of the bulb. Very good. I connected. Now only one connection is left. Please tell me what is the final connection to make the circuit into be a closed one. Bulb to battery. Okay, I'm going to take the new negative wire and I'm going to connect like this. Please everyone take down the circuit diagram. The name of the circuit diagram is one lamp controlled with one switch. Please take down the circuit diagram and name the circuit diagram as a one lamp controlled with one switch. WITCH. Please take down the title. One lamp controlled with one switch. I hope the title is visible to you people. Yes, sir. One lamp controlled with one switch. Please take down the title. So this is the name of the circuit diagram. One lamp controlled with one switch. Have you taken the circuit diagram? So now you may understood what is the difference between the actual component diagram to the circuit diagram. Circuit diagram means we need to make use of the standard symbols, and also the connecting wires are represented with the lines. The connecting wires are represented with the lines. Okay. Here I used red color and black color. If you are putting with the same color also, not an issue. For better understanding only, I made the positive wire with the red, negative wire with the black. If you are clear with this circuit diagram, now we will jump to the actual demonstration of the same circuit diagram. Have you noted down the circuit diagram? If yes means, please type yes. We will go to the simulation part. Have you drawn the circuit diagram? Yes, engineer? Yes? If you are throwing yes means, we will, yes. Okay, now I'm going to share the paint window and I'm going to share my Tinkercad window now. So I am jumping to Tinkercad simulation. So this is the three elements. This is the three element. So as per circuit diagram, if you want to keep means right hand side lamp, middle we kept switch. Am I correct, engineer? Here the 9-volt battery. Now the task is very simple. In our circuit diagram, we've had two terminals. Am I correct? So here you can see two terminals of the battery. Here I can find two terminal of the lamp. But in the switch also, but only in the switch, we have a three terminals. You don't worry about the three terminal. Consider the ground common terminal and terminal 2 as a required terminal. Please leave the terminal 1. So now I am going to make the connection. Please guide me. The positive terminal where we need to connect, please refer the circuit diagram and tell. So for the newcomer, if you want to get the wire from the particular simulation tool is very simple. Click the terminal, left click. The moment you bring the cursor nearby to the terminal, you will get a square box inside the red indication. Inside the red indication, you click. The moment you click, you will get the connecting wire like this. Once you got the wire, you can rotate the wire into your own required orientation. If you want to get an exact 90-degree rotation means, see, bring the wire up. Once you bring the wire up, you will get a blue color navigation line. If you are coming in the same line, the connection will be straight. Then, now I want to rotate the wire into right hand side. So I am going to left click once. The moment you do left click, you will get a join like a turning like this. Okay. Now you can take either left or right or even up or down you can take from this point. So once you make a left click, you will get one point. From the point you can take your direction. Now again see, now I am taking the wire to right hand side. Again I am getting the navigation line as a blue color line. I am traveling in the same blue color line. Now again I need to bring the wire little up. So again left click I am doing. Again you got a plus symbol. Plus symbol means you made a left click. Now I am moving the wire to up. That's all. So now I want to change the color of this wire. How I can change? You know very well. Here I need to select the wire. Then drop down option. I can change the color into red. Anyone remember what is the shortcut key for the red color? Can you type in the chat? What is the shortcut key for the red color to bring? 1 or 2? Which button we need to press for the red color? 1 or 2? Yes, it's 2. So 2 means you will get a red color indication. Red color change in color of wire. Okay. Now we connected the positive terminal to the one end of the switch. Now please guide me. What is the next connection? Please refer your class note diagram and tell me from the switch where I need to connect to make the closed path quick. Sir, if the guide means please tell me. From the bulb, very good bulb. So second terminal, as I told you, take the terminal 2, again click. Here I need to turn the wire. What I need to do? Left click, then I am going to turn. Okay, and straight away I am going to connect. Now this is not perfect 90-degree. You can click this dot and you can adjust. Can you see how I am adjusting? How I am adjusting? So in this way you can adjust and make it perfect 90-degree. That's all. Now please guide me the last connection. Last connection. Please guide me the last connection. What I need to do? Please guide me the last connection. What I want to do? Very to the battery to bulb. Good, very good. So what I'm going to do is I'm going to take next wire, then left click, then down, going straight, then left click, going up, then adjusting the wire, changing the color of the wire by pressing the number 1 in the keyboard. That's all. Now my connection is perfect. Hey, why the lamp is not glowing still? We made the connection. Why the lamp is not glowing still? Any idea? Any answer? Why the lamp is not glowing? I made the connection properly. On the switch. Okay, I am trying to on the switch. I'm unable to on the switch. Very good. Very good. Very first step, we need to click start simulation. Even after giving start simulation, the lamp is not glowing. That means still the switch is in open condition. I need to slide the switch. See here? Ah, very good. Then now the lamp is glowing. The moment you slide the switch from off position to on, the lamp will glow. How to make the lamp to off? Slide the switch back to the off position. That's all. Take 2 minutes time. Finish this circuit. I need your class note circuit diagram and your simulation. Both you share it as a screenshot in the chat. Please do it. Please do it. Take 2 minutes time and finish the task. Newcomer, I hope you can follow this. Any doubt also you tell me. I want response from the newcomers. Can you follow the thing what we are teaching? How to rotate the battery, sir? Kana, click the R button in your keyboard. Select the battery and then click R button in the keyboard. Yes, the value of the cell is constant, engineer. Value of cell is typical value of the cell is 1.5 volt only. Good, good, very good. Please share your class notes. It will be If you share your class note diagram, you will be happy engineer. How to switch on the bulb, sir? Deepika, I repeat once again, Deepika, please closely watch. Hey, don't share my screenshot. Sir, they are sharing my screenshots. Ashwine, please share your class notes, engineer. How to take a screenshot? Which one? Your mobile phone, you take a photo of your class note and send it. Someone asking how to, Deepika, how to switch on the bulb, sir? Deepika, see my window. In this window, you will find a start simulation option at the right hand side corner. You have a three option: code, start simulation, and send to. In that, click start simulation, followed by make the switch to slide. Is it clear, Deepika? Have you got the output? Yes, good, very good, very good, very good. Sanjay, what screenshot? Your class note screenshots. Good, Deepika. Share your output. Puzzle. Very good. Very good. Very good. Kapilesh, can you change the color of the wires into red and black? Please try. How to, sir, how to make two battery? What two battery? I will teach. Wait. How to make a connect two batteries in series and increase the brightness of the lamp? I think that may be your question. Wait, I will teach the second part. Wait. Good. Selva, color coding, sir. Perfect. Good, nice. How to change the wire color? Nitish, select the wire. Nitish, please watch here. I'm going to change the color now. Nitish, I'm going to select this red wire. Okay. And I'm going to click this wire color button, or otherwise simply you can type numbers in the keyboard. Okay. Drop down this menu and select your required color. I'm going to keep yellow color. I hope Nitish you can understand how to change the color. The second option, Nitish, I selected the wire and I am typing the numbers in the keyboard. See, the colors are changing. Okay, colors are changing. Am I correct? Nitish, try to do that. Try to do that. Very good. Okay. Yes. Now, our second task, sir, what I want to do next. Kavya, is it first time you are logging into the Tinkercad? Kavya, please check the right hand side of your menu bar. Oh, right hand side la Kavya option illa. Kavya, click designs. Click designs. If you click design, you will get an option of create. Please try, Kavya. The design click பண்ணீங்கன்னா, you will get a create option. Already you have Kavya, very simple. In your window, you are finding three options. The first option right now, what you are holding is a 3D design. Please scroll the right hand side menu bar. You will get a circuits option. In that, you click and create new project. Kavya, is it clear, Kavya? The Kavya direct on the create option got. Kavya couldn't get it. Kavya, please see here. Kavya, please, once again, I will show you. Wait. See, this is the window. Here, I am getting create option. You couldn't get it, not an issue. See here. You will find three options, Kavya, here. 3D, circuit, code block. Can you navigate to these three options? The design, when you home page இருக்கீங்க Kavya, design click பண்ணுங்க. Design click பண்ணீங்கன்னா you will get 3 options Kavya. In that you select circuits. The circuit you can create new circuit. Hello? சார் இந்த காவியா மட்டும் கொஞ்சம் ஃபாலோ பண்ணுங்க. டிஸ்ப்ளே பண்றாங்க. Others, I will give one more, second task. Start simulate post version click. அந்த டிசைன்ஸ் கிளிக் பண்ணி போனா உங்களுக்கு வரும் சார். அவங்க விண்டோல வரல. Okay. Only one person struggling. Sir will guide her. Kavya, click the design. Click the third icon, Kavya. Third icon. All, அதுக்கடுத்து 3D design, அதுக்கடுத்து circuit இருக்கும் பாருங்க. கிளிக் பண்ணுங்க. கிளிக் பண்ணீங்களா? If you click, you will get a new project. Debug bulb is not glowing. Why debug? Share your circuit. What mistake you did? How to remove the wire, sir? Select the wire, click the wire, delete. Press delete button. Someone shared the answer also. Muhammad helped. Very good, Muhammad. Deepak, can you share your diagram? We are waiting for. This is your diagram. Anna, you click start simulation. Then click the slide switch. You didn't change the position of the switch. Deepak, click the slide switch to the right hand side. The lamp will glow. Please check. Deepak, turn on the switch. Deepak, is it glowing now? Yes. Ah, sir, Lavanya coming from the beginning. Lavanya. Ram sir. நோட் பண்ணி வைக்கிறீங்களா 2 பேரு? லாவண்யா and Kavya. Lavanya, use your Gmail ID to log in. Hello? This email is not recognized. Ma, please click the sign in option in the below. Create account எதோ கொடுத்துட்டு. Hello? Create account எது கேட்க. Lavanya, can you wait for some time? We will teach you how to do that. Lavanya, you do one thing. In the same screen, you click create account. While you click the create account, you will get a Gmail ID logins. There you use your Gmail login and login. If not, I will share one number. Please make a call to that number. Sir will guide you. Okay? Kana anyone struggling there to make a login means I will share Mundra sir number. Sir, can you share your number? Sir will share his number in the chat. Please make a call to him. He will guide you individually. Okay? Okay. Now I am going to continue the class. Others, don't worry. We will make you to finish this task today itself. Okay. Sir, please share your number, sir. Dear engineers, if anyone facing the trouble, please make a call to sir's number. It is in the chat. Now I am going to definitely I will give you a time to finish this task. Don't worry. Please dial sir's number. He will guide you. Okay. Yes. Now the next task is please stop typing messages in the chat. Now someone asked, sir, how to use a one more battery? How to use a one more battery? It's very simple. See here. Whenever you are drawing a circuit diagram, it will automatically save in this cloud software. Next time, if you want to make use of this, please click the tinker this option. If you click tinker this option, you can continue the same page to do the modifications. Okay. Now listen. Now listen. I'm going to take this 1.5 volt cell, but here it is mentioned as a battery. Don't worry. I'm going to take the lamp and I'm going to connect it across this. Is it clear what I did right now? I repeat once again. I repeat once again. I took a cell. I took a cell from the component list. Then I took a lamp. I hope the screen is visible. Tinkercad screen is visible. Yes, sir. Yes, sir. Yes. Now we have only one cell, and I am going to start simulate. The lamp is glowing with a very light brightness. Now I want to increase the brightness similar to the 9 volt. How I can do that? Very simple. Same circuit diagram. Same circuit diagram. One more time I am making same cell, the lamp, but this time I am going to click the cell and I am going to increase the, now I am going to increase the, 1 minute, it's not changing, wait a minute, yes. Now I am going to click the cell, I am going to click the cell, so, wait a minute, please. If try to click the cell, the moment you click the cell, no, you will get an option. You get an option to increase the number of cells in the holder. It's not coming for me. Let me take one more cell. See, here you will find number of battery. Now I'm going to increase this into 2 and I'm going to start simulation. What is the difference between the first two lamp output? The first one is very dim. The second one is little brighter than the first one. Again, I am going to stop the simulation. I am clicking the cell holder. I am going to click the cell holder and I am going to increase this into 3. So 3 means now if you put a two cells means you will get a 3 volt. If you increase in the third cell, as we discussed earlier, you will get 4.5 volt. Okay. For me, little network disturbance. Wait a minute. I'm not getting the. So now I am changing this into 4. 4 means how many voltage? 1.5 plus 1.5 plus 1.5 plus 1.5, 6 volt. See here, the moment I start simulate, the brightness of the lamp is varying. Am I correct, engineer? Try to do this task. First task 1.5 volt, second task 3 volt, the last one is 6 volt. If I keep on increase the voltage, the brightness of the lamp varies. Please try to witness this exercise. Quick. சார் அந்த காவியா கூப்பிட்டாங்களா? காவியா, have you tried? காவியா யார் இன்னொருத்தவங்க? Kana someone tried with the 2.9. Kavya, are you got how to? Sanjay, once more, sir. Wait, sir. Sanjay, see here. I'm going to delete all. Okay, I'm going to delete all this. I'm going to do step by step. Okay, I'm going to take one cell, connect like this. Then start simulate. The lamp will glow. Okay, please observe the intensity of the lamp. The next step, I am going to take the same cell, but I am going to increase the number of cells into 2. Okay, it is like our TV remote. Okay, yeah, the operating voltage of the TV remote is the 3 volt. Now I increase it to 2 cells in series. So the operating voltage becoming 3 right now. So see the brightness of the lamp. Earlier case is 1.5. The second case is 3. Now again I am taking the same cell and I am going to use the same cell holder. I'm going to insert 3 batteries inside, three cells inside. Take the lamp, connect. What you inferred from this? Please tell me. If I increase the voltage, what happens to the brightness of the lamp? What happens to the brightness of the lamp, whether it is increasing or decreasing? So now I am keeping the maximum voltage. I am keeping maximum voltage, that is 4 cells I am going to keep inside. 4 cells I am going to keep inside. I am going to take this cell, making into 4, and I am connecting the same lamp. Try to do this. So slowly the brightness of the lamp is increasing from first case to second case to third case to fourth case. Please try to do this. Are you getting the brightness increasing? Very good. Slowly it is increasing. The first one is 1.5, second one is 3, 4.5. Very good. Done. Yes. I hope you people able to do these 2 stars. Now anyone try the same battery holder, if you select some option, you will get a on off switch over that. Try to find it. The same cell holder, stop simulation. Try to introduce the switch in this, not external switch. The simulation tool itself, they gave the option to introduce the switch in it. Try to do that. Try to do that. The same cell, in the same cell, we can introduce the switches in it. Try to do that. Can you find the switch in the same option? On off switch. Inbuilt switch, sir. Yes, sir. Inbuilt switch. We need to turn on the inbuilt switch. Good. That's very good. Muhammad done. Sriharan done. Very good. Sriharan done. Pragadis. Good. Very good. So in this way, you people can play with this tool. Actually, how these changes are happening? Anyone can tell, please? How these changes are happening with no time? I don't have an actual component, but I have a virtual components. How these things are happening? Any guess from your side? It is very much related to the content what you learned in the first week. First week, what you people learned? Software. Very good. Nothing but a coding. Very good. Very good. Program. Yes. This software has a inbuilt code. What you people are going to do in the near future, you may get a job in any one software industry. That industry will give you requirement like this. Scratch code. Yes, scratch code you learned. Scratch code. Scratch code is a fundamental coding technique engineer. That also we will teach you today. Okay. I hope the yesterday's absentees or day before yesterday's absentees and all are in the same line right now. Git and GitHub. How you know Git and GitHub? Paulus Vijay. Very good. Git and GitHub. By electronics microcontroller inside the computer. Good. Very nice answers. And now we are giving a 2-minute time for the yesterday's struggle people. Okay, yes, they thought GitHub also. Good, very good. Do you have a LinkedIn profiles? My dear engineers, do you have a LinkedIn profiles? Do you have a LinkedIn profiles? Yes, sir. Whether they taught how to write a LinkedIn for this training program, or you wrote any LinkedIn messages? No. Okay, today we will teach you how to write a LinkedIn with a sample thing we will teach you. Okay, stop. We understood they didn't teach you. We will brush up that how to write that. Only one thing, I only changed the banner. What banner? What is Varan? Oh, photo image in the LinkedIn you changed it. Okay, good. Okay. Sir, and yaar Kavya, yaar இன்னொருத்தவங்க struggle. Kavya, have you got the circuit diagram? How to simulate Kavya? Kavya and one more person. Sorry, I forgot the name. How to combine the battery? I'll teach you. Wait. Have you got Kavya? Please, can you share the screenshot of your simulation? Please share the screenshot, Kavya. Anyone is struggle? If anyone is struggling with the Tinkercad simulation, don't share any other images, surveys. Please don't share other images. It's a common forum that we are recording the session. Please don't play. Kavya, can you share the screenshot of your simulation if you done means? Yes. Okay, let her share. Any other student are struggling with the Tinkercad simulation? Any other engineers? If you are facing issue means, please share your name in the chat. Pundra sir will support you how to do that, because now we are going to get into little advanced concept. Sanjay combine பண்ணாம விட மாட்டார். Okay, Sanjay, please listen. How to combine the battery? From the beginning, he is asking same question, sir. Sanjay. Sanjay, see here. How to combine the battery is your question, no? See, take one battery, Sanjay. Control C, Control V. Shall I teach with circuit diagram first and then explain with this one? Wait. How to combine the battery? How to combine the battery? Let me teach with the circuit diagram. Then you can perform using your own simulation. Okay, let me teach the circuit diagram. Thereby you people familiarized with the circuit diagrams. It is very much important. Understand the circuit diagram and then drawing your own simulations. Okay. Now what I am going to do is, our Sanjay question is, so how to combine the battery, sir? Very simple, Sanjay. I am going to take one battery. This is the first battery, Sanjay. Our 9-volt battery. Then I am holding the second battery in my hand. How I am going to connect? Please check, Sanjay. This is my second battery. Okay. Now the remaining things are same. The same switch and the lamp. Sanjay, please observe. Sanjay, please observe. The positive plate of the battery I have connected with the switch. Then other end of the switch I have connected with the lamp. Then the negative terminal of the first battery. Let me consider this as a battery 1. Sir, paint is visible, no? Paint screen is. This is battery 2, Sanjay. The negative terminal of the first battery, you need to connect it with the positive terminal of the second battery. Only this connection is a new connection to make these batteries together. Take down the circuit diagram. Take down the circuit diagram. Take down the circuit diagram. Then negative terminal of the second battery, you need to connect it to the lamp. Is it clear, Sanjay? Please everyone take this circuit diagram and then simulate the same and show me the output. I hope I cleared the doubt for the Sanjay, and also consider this as a next task and do it, please. I hope you people took a circuit diagram. If you are taking much time, means take a screenshot of the diagram and then draw in your notebook. and then draw in your notebook, please. If anyone finish this task, share your output. Sir, sir, why the lamp giving the warning symbol Muhammad Hussain? Very good, Muhammad Hussain. Why the lamp giving the warning symbol? Any idea? High voltage. Very good. High voltage. For your kind information, it gonna blast. Yes. Practically, if we do, it will blast. What is the reason behind that? Is very simple. The operating voltage of the particular bulb is a 12 volt only. If you connect two batteries in series, let me do the same simulation. Yes, very good. It is 18 volt. So 9 plus 9, 18. Obviously, it will damage the filament inside the lamp. Can anyone tell me what is the name of the filament present inside this lamp? Anyone? Yeah, anyone can please? What is the name of the filament present? Tungsten. Very good, engineer. Very good. Tungsten. Tungsten is the not fluorescent, Kishore. Fluorescent is the gas name what we are using in our tube light. Tungsten is the right answer. Come back. Come back. I will teach you this concept very clearly. So positive. We need a switch, no? We need a switch. Take this light switch. Take this light switch. That's all. So now what I'm going to do? I'm going to take the positive terminal to the one end of the switch. One end of the switch, followed by the other end of the switch. I am going to connect it to the one end of the lamp. Done. Done. Then this negative terminal to this positive terminal. Then negative terminal to negative. I hope this connection is clear to everyone. The moment I turn on the lamp, it is giving warning symbol. Please take the screenshot of this warning symbol. Current through the light bulb is 353 milliampere, while the maximum limit is 250 milliampere. Yesterday, we read the same kind of error message for our LED. Am I correct? The current rating of the LED is only 20 milliampere. If it is exceeds that, LED will get damaged. Similarly, the operating voltage of this lamp is only 250 milliampere. If you are giving more than that, it will damage your lamp filament. Is it clear? Yes. So in this case, how to reduce the voltage? Very simple. Here, if you are using 9 volt battery, the combinations will be in the 9 term, 9, 18, like that only it will keep on increase. For that purpose, we have one more power supply unit. Please select all option. Go down slowly. Then you will find the instrument. Under the instrument, you will find power supply. I will share the screenshot of this. Menu. Click all option. Under the all option, find instrument. In that you will find the power supply. Take that power supply. The power supply itself, we have a switch. Okay. So I am taking only lamp alone. I'm going to connect the lamp with the power supply. See here, positive to positive, positive to positive, I'm going to connect. Then negative to negative. Yes. Now start simulate. This power supply has two rotating knobs and one on-off switch. If you make the slide switch, the earlier we learned the slide switch, no? Same kind of slide switch is available here. If you make it on and off, the lamp will turn on. Here, you can increase the voltage by adjusting this knob. பாருங்க இப்போ எவ்வளோ வோல்டேஜ்க்கு மேலே போகும்போது டேமேஜ் ஆகுதுன்னு பாருங்க இன்ஜினியர். எவ்வளோ வோல்டேஜ்க்கு மேலே போகும்போது டேமேஜ் ஆகுது? எவ்வளோ வோல்டேஜ்க்கு மேலே? எக்ஸாக்ட்லி எவ்வளோ வோல்டேஜ்க்கு மேலே போகும்போது இப்போ டேமேஜ்? 12 வோல்ட். வெரி குட். 12 வோல்ட். If it not 250 volt, 12 volt. See, 250 milliampere is the current rating. Very good. Current, you skip the current rating, check the voltage alone. So the one way to adjust the voltage is you can adjust this knob, or else you can type the value in the box itself. Type 12. Now this is the rated voltage. The rated current is 250 milliampere. There is no damage to the tungsten filament. If you slightly increase the voltage, your simulation will do the warning. See, I'm giving just 12.1. The current exceeded to 2 milliampere additional. The filament got damaged. So with this, the fundamental electronic portion is over. Okay. Today we want to teach you the second concept. The second concept of our today's content is programming electronics. Take a fresh sheet in your take fresh sheet. Do you want to try this exercise, this power supply exercise? Please take 1 minute time and do it. Please take, if you want, please take this power supply exercise. Exercise. Voltage பார்க்க சொன்னா கரண்ட்டும் பார்க்குறான். Good. Please take 1 minute time. I'm complete. Very good. So now the second part of our content, Mundra sir will deliver to you. Please take motor la vachi run panna aarambichanga. Kana motor we will teach you, don't worry. So now I want to clear only one fundamental theory concept, that is law of energy conservation. Can anyone recollect the law of energy conservation? Can you type it in the chat box? Law of energy conservation. Energy neither created nor destroyed. It can be converted from one form to another. Am I correct, engineer? Yes. Neither created, energy cannot be neither created nor destroyed. It can be converted from one form to another. What we are doing from the last 2 days is we used the battery. Am I correct? What energy we are storing in the battery? What energy we are storing in the battery? Chemical energy. The chemical energy is converted into electrical energy via the wires once it start travel. That particular electric energy is again converted into light energy. That's all. So we understood the law of energy conservation also. If you are giving, some people did the simulation with the motors. So in motor, what type of energy conversions are happening? Electric energy is converted into, any idea? The motor, what type of energy conversion is happening? Not a heat, magnetic energy. Very good, magnetic energy. But a exact outcome is a mechanical energy, physical energy. That is your mechanical energy, the rotation. Okay. So with this, we have few more fundamentals. In between the time we will learn, that is your Ohm's law, Kirchhoff's laws, and the continuity tester, like kind of little theory concepts are there. In between your regular sessions, we will interrupt and we will teach those concepts. So with this, I am going to signing off. Our next instructor, Mr. Moondraj are going to take care of our session. Thank you very much.
Thank you, sir. Am I audible, sir?
Yes, sir.
Okay. So, welcome to all the students, and we are going to move to the very next topic, which is Arduino. Okay. So, before start of the things, I want to ask you some question. Now, you people worked with switch and bulbs, right? Bulbs or LEDs or whatever it is. Can someone say, if I want to turn on the LED or the bulb for about 1,000 times, what you people will do? Just let me know in the chat. I want to turn on the bulb or the LED 1,000 times. What you people will do? 1,000 times on off. Yes. Okay. Potheswaran, you got it. Wide loop by using Arduino. Okay. Good. So many of you may aware of Arduino. Okay. So you answered properly. Correct. Good. Kishore, 1,000 times on off. That one is correct. By a human being, is it possible to turn on 1,000 times? That we have to think of. Okay. There only we are going to introduce something called, maybe you can say it is Arduino board. Okay. Arduino use pannalam, Sanjay. Yes, exactly. Yeah, we have to give the condition in Arduino. Yes, exactly. Many of you, gave your answers correctly. Okay. Now we will have some basics about Arduino, and Abdul Mohit posted with the Arduino board itself. Okay, good. Very good, very good, very good. Okay, now let me present the screen. Then we will move on one by one. Okay. Okay. Give me a few seconds, Kana. Sure.
Abdul, is it a real circuit diagram you have, or you got it from somewhere?
Okay. Okay. Is my screen visible to everyone? Okay. So we will move on, right? So as I have asked you people, we want to make the bulb or the LED 1,000 times. For that, you people said we have to use Arduino, correct? So that is the thing we are going to learn today, and we are going to start learning today. Okay. So before get into Arduino, we must know certain things. Okay. So this will be our agenda. Okay. Maybe with one or two sessions it will go on. And first we have to know something called microprocessor and microcontroller. Maybe many of you have a word called microprocessor and microcontroller, correct? Then we are going to get into the Arduino development board actually. And then we have to know certain functions that are going to be useful for programming. And finally, we are going to demonstrate or simulate some of the applications using Tinkercad platform, as you people are aware of it, right? So we are going to use that. And then you people are going to do the hands-on. Okay. So this will be our agenda for the coming 1 or 2 days. Okay. So can you people able to see this? What it is actually? Can someone say what it is going to do? Whistle, okay. Pressure cooker blast, okay. Pressure cooker, okay. Okay, cooker, correct. Okay, so this is a cooker, right? Okay, you people may aware of it. Okay, cooker. Why it is called cooker? The question may be of a very chilly question, okay, but why it is called as cooker? Yeah, Pothishwaran, correct. Because it is cooking. Because pressure used to cook, it cooks rice. Okay, well and good. So, in electrical and electronics, no, for each and every name has its own meaning. Okay. So, because it will cook the raw foods, so it is called cooker. Okay, good. Okay. Now, can you people able to see this animation? We are having some things, okay. We people may aware of it also, input, memory and output, okay. The memory on the upside, we have something called CPU also. CPU refers to central processing unit. If you press a word or a key in your keyboard, how it is going to be processed? That will be the animation given here, okay. So, uh, to perform this thing, okay, you can find number of ones and zeros flowing through from memory to output device as your display. Okay, so to perform this, we are in need of certain circuit. Okay, that is going to be called as processor. That is going to be called as processor. Okay, and we will see certain examples also. Okay, so now because of cooking, the device is called a cooker, right? So what we are going to have is a chip, the IC, integrated circuit, which is going to do process. So it is called a processor. Okay, basically, right? Okay. So we may call it as a CPU. Okay. Now, can you people identify? I have listed 4 examples. No, what these 4 examples are going to do. Then we will conclude. CPU, correct? Yes, exactly. Now I have listed something, right? Can you people identify? 3D printer, okay. 3D printer I have not listed. Gives output, okay, correct. Thermometer, exactly. Sensor, okay, good. Washing machine, exactly. Okay, billing machine, okay. Ticket billing machine, okay, good. Billing machine, correct. Washing machine, portable washer, yeah, door, automatic door, correct. Okay. So now I will show some other things, okay. See, I have listed 4 diagrams here, right? Forget about the left 2 diagrams, microprocessor, microcontroller. Concentrate on the right 2 diagrams. Okay. See, the very first one is your computer, correct? The second one is going to be a car key, correct? So we have discussed or we have seen number of applications, correct? Yeah, BWM car key, BMW car key, yes, exactly, correct. Um, we have seen so many applications. No, first I have said you processor, okay. Next thing, that processor used device is called a computer. We may say it as a computer, okay. What will be the basic difference between a computer and a washing machine? Can someone say? What is the difference between a computer and a washing machine? Yes, computer uses internet, okay. Computer process memory. Okay, good. Washing machine have fixed program. Nitish, correct, exactly. Right. So, see what type of function it is going to do. Based on that, it is having two categories. Okay. First, we will come to washing machine. Washing machine is the device which is going to wash the clothes. That's all. That is the only thing it is going to do. Okay. So it will always do the same thing repeatedly. Correct. Even after 5 years, the washing machine is going to be washing machine. Even after 10 years, it is going to be the same. Okay. But think about a computer. Now you people are sitting with your computer in your room, correct? So what are all the different functions that can be done by a computer? Just type in the chat. Yeah, computer can perform task. Okay, different task. Does many jobs, coding. Yes. Information process use பண்ணலாம். Yes, exactly correct. Then Kanna, what else we can do? Billing, gaming, okay, communication, correct. Okay. Is my voice is audible? Several purpose. Animation, movie, watch, coding for all technical jobs. Yes, exactly. For building, programming, coding. Yes, yes. Okay, okay, done. Right. So now you people had two different things. Okay. One is the washing machine, which is going to do only one job. Correct. But on the other hand, the computer is going to do many jobs. See, the computer is going to reflect the person's mind, the person which is going to use the computer, based on his or her mind, your computer is going to act upon. Okay. Say for example, if I am a book reader, okay, I love to read books, then once I open the computer, no, I'm going to read the books. Correct. If I am a coding addict, then once I open the computer, I will do programs. If I am a game addict, I'll open the computer and play games. Okay. So whenever my thought process is going to change, my computer process is going to change. Okay. So the computer is the one which is going to support many different functionalities. So we can conclude that computer is a general purpose device. General purpose device. On the other hand, the washing machine is going to be the specific purpose device. Specific. It is going to do only one job. So here in the slide, I have listed computer as well as the car key, right? BMW car key. Okay. And now you see computer is the one which is going to do lot of jobs. So it is a generic machine. But the car key is going to do only one job. When I press the key, it is going to open the door. One more time, if I press the key, it is going to close the door. That's it. Okay, correct. So this functionality may not be changed. Whoever is going to use the key, okay, the one thing they can do is open the door and close the door. That's all. Correct. So whether these two things are clear? Yes. So we are having two certain things. One is specific application. One more is generic application. Okay. In general, generic application devices are going to use processor as the main part. Okay. Specific application devices are going to utilize controller on the other hand. Okay, clear? This is where processor and controller comes into picture. Okay, so in the same slide itself, I have shown you microprocessor, the structure. Okay, you don't think too much of it. Okay, right now, too much of information is not needed for us. So on the left side, we have something called a microprocessor. On the right side, we are having microcontroller. Okay, you see, you can observe microcontroller is going to have the CPU, right? The CPU is or otherwise called as processor. So microcontroller have processor in it. Also, it can do a lot of other functionalities as well with the help of memory, IO, and peripheral devices. Okay. On other hand, the microprocessor is going to do only process. You can see that the memory, IO, and peripheral devices are missing in microprocessor. Okay. So this may be called as a block diagram. Now we may not need of much information. Okay. So with this, I will conclude this particular slide. Okay. So far what we have discussed is microprocessor, microcontroller. Okay. The microprocessor is going to be useful in the machines that are going to be built for generic purposes. Okay, so best examples are your laptops and computers, PC, and your mobile phone. Okay, all these things are comes under what? Generic purpose. The nature of the device can be vary. Okay, right? On the other hand, controller is used where it is going to do only one job. Okay, it is going to do only one job, right? So that is going to be specific application. Okay, so from now onwards, if you people seen any application, no, you can find whether that particular thing is used processor or controller. Okay, and I will give you one more clue also. Nowadays, okay, in recent days, we are having processors in certain single purpose application devices also. For example, how many people are familiar with the projectors? Yes, projectors. Maybe in your school days you can find projectors, right? What is the purpose of a projector, Kanna? What is the purpose of projector? Big screen to watch movies. Yes, it is going to it is going to show you the content which is going to be given from the computer. Correct. So that will be projector's purpose. Okay, the projector may not be built only with the microcontroller. It also going to do only one job, that is going to project the screen. Okay, but it will use processor. Those processors are called application specific processor. Okay, application specific processor. Clear? So you can, based on the purpose, you can classify whether we are having processor or the controller. Okay, and now we'll move on. I hope these two things are clear. Okay, right. Now, so we are going to study Arduino. Okay, so it will be preferable one. Why it is preferred so? Okay, for that we need to know certain things, right? Why Arduino is preferred among beginners? Okay, first thing is it is open source. Open source means both software and hardware, both are going to be open source. Okay, what do you mean by open source? Can someone type what you mean by open source? Open source அப்படின்னா என்ன கண்ணா? What you could understood the word open source? Free to use. Yes, exactly. Everyone can access it. Very good, very good, very good, very good. Okay, without paying anything, yes, we can use it. Correct. Okay, so we don't want to get license, okay, from anybody or from anywhere to use this particular board. Okay, so the board refers to the hardware. Okay, the software which we are going to use the board to program is called a software. Okay, both of course has no need of getting license. Of course we need to pay money for buying the hardware. Okay, the hardware needs to be buy from some shop. Okay, but usage of the hardware, usage of the software, okay, we don't want to pay a single penny for anybody. Okay, so that is the foremost thing to popularize this particular board. Okay, so also it is going to be cheap. Okay, basically we may not aware of it. Okay, but generally the development boards or the boards, microprocessor, microcontroller boards like this are going to be costly somehow, maybe greater than 4K or 6K or whatever it is. Okay, but this is going to be very, very cheap. It will be available in the market for about 400 to 500 rupees. Okay, and communication, you can simply connect this board with your computer with the help of one cable. That's it. I hope that cable is also given to you. It is USB cable. Okay, and this can be powered from USB cable itself, or else with the single battery we can power this device, or we can use adapters also. Okay, so that will be the very easy thing to power this device. Okay, it is going to work with the 5 volt. Okay, and the most important point is easy to learn by self. Okay, so once you know certain basics, no, you can learn by yourself. You don't want anyone to teach you. about this particular board as well as the programming concepts. Okay, I hope some of you may aware of it. Okay, already. Anyhow, we need to concentrate all the 600 or 700 students, right? So we will start from the basics. Okay, so this is what I wish to convey regarding the Arduino. So there are only two things, two key points that is going to be useful for us to work with Arduino. One is it is open source. Second one is it is going to be learned by self. Okay, right. So these are all different varieties of Arduino boards. Okay, in the market we are having lots and lots of boards, right? So the one which we are going to work is Arduino Uno. Okay, this is the one we are going to prefer to use. Okay, it is easily available. Of course, other boards also available. In Tinkercad, we are having Arduino Uno board. Okay, so we are going to start with that. Okay, you people may familiar with other boards as well. If you know Arduino Uno, then you can have a hands-on with the other boards as also. Each board is given for respective functions. Okay, there are a lot of different functionalities. Some boards may have internet connectivity, Wi-Fi chipsets, and some may support computer vision. It can be used with the AI. Okay, some boards may have sensors also in it. Okay, so directly without connecting anything, you can directly work with the particular boards. Okay, of course we can build a computer too with the help of this particular rock 3 model, single board computer it is. Okay, right. So these are all the board's details. Okay, then the board which we are going to use is Arduino Uno. Once again I'll show you that in Tinkercad in few minutes. Okay, and before that we have to know certain things. Okay, so once again this is too much of information, but anyhow we have to at least spell a word related to this, right? So we may say it is specification or features of Arduino. Okay, specifications are features. Okay, so the Arduino Uno is a development board. Okay, that development board is going to have one microcontroller chipset which is called Atmega 328P. That is the microcontroller name. Okay, and the memory it is going to have is 32 kilobyte of flash, 2 kilobyte of SRAM, 1 kilobyte of EEPROM. Okay, and the CPU is going to be run with a clock frequency of 16 megahertz. Okay, then it is going to have a power on reset and brownout detection. Power on reset in the sense once you turn on the kit, it is going to be automatically reset at once. Okay, brownout detection means it is one of the specific power faulty identifying mode actually. Okay, that it is going to be much information. Then these are all the peripherals it is going to have. Peripherals on other hand means we can connect something with the Arduino board. Okay, for connecting directly we can't able to connect anything with the microprocessor or microcontroller chipset. Intermediary we have to use certain things. Those things are listed here. We may say it is called a port pins. Okay, maybe in few minutes we are going to see something called analog pins and digital pins. No, that under all may be called as a peripherals only. Also, it is going to have a timer. Okay, so we can generate time signals as well. Okay, and so this is going to be your Arduino board. Okay, now from here onwards, we will use the Tinkercad for checking the Arduino board. Parallelly, you people can also pick the board and you can keep it in your screen. Okay, let me share the screen once. Just a minute.
Kana, sorry for the interruption. Uh, you people will receive our maker kit box from our institution. It consists of your Arduino Uno board, multimeter, resistor, and few more tools also available. Don't buy any components from your own. The moment you join, we will give you the maker kit. If you want to practice something from your side means buy only the 9-volt battery and very low LED and other stuffs, simple components. Other than that, you don't buy any component. Okay, yes, sir, you can see.
Thank you, sir. Is my screen visible? Okay. So as sir told, no, you will be provided with the maker's toolbox. Okay, the box is going to contain all the basic necessity components what we are going to teach you. Okay, so you can practice here in person with the help of the faculty support. You people are going to learn all such things. Okay, so till then, use Tinkercad for playing everything. Okay, right. So as usual, you people know, right? We are going to work with the circuit only. So go to create circuits. Okay, a new window is going to be opened. See, even once I open the window, no, one message is popped up. It is new microbit component. It is also one of the, see, it is also going to be one of the microcontroller. Okay, see, the things are going to be much simpler. If you place it and it is going to have certain code, right? Basically, if you start simulated, it is going to give you some smiley. Okay, so you people can program this also. Okay, you can just play with this, right? So later on, we will come with this particular board. Okay, now our aim is to learn Arduino, right? So we will delete this and we will go with the Arduino. Okay, so once if you people can't able to find the component here itself, you can go to components and list. See, the first list is going to be given as a basic name, right? So you can click all, you can find all the components is going to be available or listed with this particular Tinkercad. Okay. So our aim is to pick Arduino board, right? You can find Arduino Uno R3 here. So click on it and you can place it on the screen. Now you can find the screen is visible to you, I hope. Okay. So we will know certain basic things about the board. Then we will get into the very first task for us, right? Okay. So now you can find, see, my mouse pointer is visible, right? Yeah. Okay. So this is your USB cable. Actually, it is type B connector. This the portion we need to connect the USB cable to power up this board. Okay. This is one of the very first powering method. Also, I can provide a 5 volt underground directly using this power pins also. Okay. 5 volt underground. But we need to provide only exactly 5 volt DC with the ground. Okay. That we must make sure, right? And the third powering method is going to be the DC adapter. This one now you can find these type of connectors you may see, right? It is going to look like a pin, right? It may be connected with the 9 volt AC or DC power adapters. Once you connect with this, also the board can be powered up. For programming, we need to use USB cable only. Clear. So we are having three different ways of powering the board, but we should not power the board using all the three methods in a time. Okay. In a single point of time, we have to use any one powering method. Okay. So that we have to make sure. Okay. Then you can find something like this. Okay. The red color dot. Actually, that is the reset button. That is a reset button. Once you connect the board, if we want to do the manual reset, no, we can press this button and the board is going to be resetted. Okay, fine. Then this particular board gives you with the 4 LEDs, 4 number of LEDs. Okay, on the right side you can find something called on. The labeled thing is on, correct? So this is one LED and L refers to one more LED. TX RX is 2 more LEDs. Okay, totally we are having 4 number of LEDs. Okay. So basically the function of an LED we may know, right? It is to indicate. LED is the purpose which is used to indicate certain things, correct? So the board is powered. It is going to indicated by this on LED, power on LED. Okay. And this RxTX, no, this RxTX is useful. Okay, I'll tell you, I'll come to that point a little bit later. If this board is going to transmit, that will be referred by TX, receive, that will be referred by RX. If this board is going to transmit and receive, okay, at that point of time, these two LEDs may blink or glow. Okay, and the L refers to user LED. L refers to user LED. Okay, So this LED, no, it is an onboard user LED. We people can make use of that LED for verifying or testing the board. Okay, that we will do. Today we will complete that, I hope. Okay. Then the other technical details we must know is on the top part, you can find number of connectors, you see. Yes, these are all connectors. While I move the mouse now, it shows D0, D1, D2, D3, D4, like. Okay, these are all digital IO pins. We can say it is called digital IO pins. IO refers to input output. IO refers to input output. Okay. Digital refers to it can accept or it can give you. Okay. Input means it is going to accept. Output means it is going to give us, right? It can give us two logic. Okay. Either high or low. Okay. Basically, whatever the things we are discussing, if the answer is a true or false, yes or no type, okay, then that may be called as a digitalized answer. Okay. So digital, wherever you find the word called digital, okay, we may conclude that it is going to have only two possibilities, on, off. One of digital possibility. Okay, high, low. One of digital possibility. True, false. 0, 1. Okay, so these are all called digital. Okay, so these pins are used for from number 0 to 13. These are used for digital IO pin connections. Okay, and with that respective pin, there is some symbol has been represented here, right? So that is called a tilde symbol. That is called tilde symbol. That symbol represents PWM. It is pulse width modulation signal. So these respective pins can be used to generate PWM signal also. At later point of time, we may discuss about PWM. Okay, not now, right? Okay, so totally we are having 14 number of digital pins. We are having 14 number of 0 to 13, 14 number of digital pins. Of course, these pins are going to have not only one function, it may have more functions also. Okay, the best example is if you could understand 0 and 1, no, so 0 1 can be used as a IO pins, input output pins. Also it is marked with something called TX and RX. As I have already told you, right, we are having two LEDs called TX and RX. These two LEDs are related to this particular pins only. Okay, TX and RX. So TX means transmission in the sense from the board something is going to out. Okay, so the signal is going to be sent out, that will be transmitting. Receiving, on the other hand, it is going to, the board is going to receive something from the external pin. Okay, so that will be received. So these two pins are used for transmission as well as reception. Also these two pins are used for IO pins as well. Okay, so that will be multiple functions. Okay, right. So these are all digital pins, and the last two pins are analog reference. This will be analog reference pin and a ground pin. Okay, and on the bottom you can find analog in, correct? Analog in. So they will be provided with 6 analog inputs, A0 to A5, and we have to understand that digital and analog. So the difference between digital and analog is, if the say for example, I'm going to use one switch. Okay, using that one switch, I can do two possibilities. What are the two possibilities? Can someone type? Using the switch, what are all the different possibilities I may have? Okay, on off. Very good, very good. So on off, right? There are only two possibilities, correct? Okay. In the slide, no, we have shown something called a thermometer, correct? What value it can show? What value it can show? What are all the different possibilities of values it can show? Definitely it is not going to be fixed with two values, correct? Yes or no? Thermometer is the one which is going to give you different values, correct? So different possibilities of values. Okay, say for example, consider I'm having 0 and 1. Okay, 0 and 1. If I consider only these two numbers, no, I can say it is digital. Just now we have discussed about it. Okay, if I say in between 0 and 1, how many values we may have, the possibilities of values in between 0 and 1. There will be lot of values, right? We can't able to conclude. Say, if I say only 2 decimal numbers give me like that. Yes? Yeah, infinity. Yes, exactly. That will be the correct answer. Infinity possibilities. So there will be, if there will be infinite possibilities, those things may be considered as analog possibilities. Okay. If I see only 2 possibilities, no, then it can be called as a digital possibilities. Right. So in the board, na, on the top side, whatever the pins we found, those pins can be works with only 2 possibilities. Okay. But on the bottom, we are having A0 to A5, right? These pins may be used whenever we see lot of possibilities, infinite possibilities. Okay. So there they have mentioned something called analog input. Okay. While I mentioning digital, no, I have mentioned it as IO. That means input as well as output. But here they have purposefully mentioned it as analog in. Okay, that means it can receive or it can get only the infinite possibilities. It may not give output as analog. Okay, it may not give output as analog. It can get only analog input. Okay, fine. Then the remaining portions are power pins. Okay, so here we may find 5 volt ground, V in 3.3 volt reset and IO reference. Okay, so these power pins are maybe used to power up the other devices, other input output devices. If we are in need of 5 volt, we can take out 5 volt. If we are in need of 3.3 volt, we can take out 3.3 volt. Okay, that's it, right? So the main hero of the particular board is this fellow. Okay, as I have mentioned one thing that, right, Atmega 328P microcontroller, this is the microcontroller chip. Okay, so this one is going to get our program and it is going to make the devices to work according to our program. Okay, I have asked you one question, right? Before start of this content, I want to switch on 1,000 times, right? So that 1,000 I can feed, I can tell this person, okay, 1,000 times on and off the switch. If I say that particular controller is going to do the job for me, okay, and how I can provide the program to this fellow, no, I have to use something called programmer. Here we can find a small chip, a square shaped small chip, right? This will be called a programmer. So these two fellows needs to communicate themselves. Okay, these two fellows needs to communicate themselves. So how my program is going to get into this part? No, I am going to connect my computer with the help of this USB cable, correct? With this USB cable. Okay, this USB cable on the other hand give my program to this fellow called programmer IC. Okay, this is also one of the microcontroller only. Okay, so what he is going to do is he is going to get our program from the computer and he is going to put that code into this controller. So these two fellows needs to communicate. No, he is going to transmit, at that time he is going to receive. Okay, so these transmission and reception will be done by this TX and RX pins. Okay, this TX and RX pins actually. So while it transmit and receive, no, at that point only we can find that these two LEDs are going to blink. Okay, so these two LEDs are going to convey to us that these two fellows are communicating themselves. That will be the primary idea. Okay, fine. So this is programmer section, this is controller, this is analog input pins, power pins, and digital input output pins. And this one will be your power section. If I connect a 9 volt AC or DC, okay, that needs to be given converted to 5 volt. This board is going to works with 5 volt only. Okay, so whatever may be the higher voltages I'm going to connect, 9 to 12 volt possibility will be there. Okay, if I connect more than 9 volt to 12 volt, then this section is going to convert that 9 to 12. If it is DC, it is going to work as a DC to DC converter. 9 will be converted to 5. If it is AC, that AC must be converted to DC, right? 5 volt DC. Okay. So that portion will be done by this chipsets. Okay. So we may have a regulator and a bridge rectifier. Okay, so that section is this one, and this one, right? This is called crystal. They have mentioned something called SPK 16.000G, right? It is crystal. In the slide, right, I have mentioned one word called the Arduino is going to works with a clock frequency of 16 megahertz, correct? So this is going to be the 16 megahertz crystal. Okay, so crystal is the heartbeat of your controller. Okay, it is going to give you clock, right? It is going to generate the clock frequency. Based on the clock frequency only, the circuit or the controller board is going to work. Without this, nothing is going to work here. Okay, so this is regarding the board details. Okay, so far everything clear. Do you people have any doubts?
Can I please share time over, sir? Time. Wait 1 minute. If anyone have a doubt, please share it in the chat.
See, we'll
Short.
spend few minutes, okay, few minutes so that we can blink the LED. Okay, that is also we are not going to see much deeper code techniques. Okay, we will discuss only the board code which is going to be already available. With 2 minutes, we will close. No doubt. Okay, so everything clear. So far, everything clear, right? Okay, okay, fine, fine. Okay, then we'll move on. Then, okay. Now this board must be programmed, right? So we need to program the board. User, we are the user. We need to program this board. Okay. For get into programming, okay, on the top right corner you can find something called code and start simulation. Already you people may aware of the start simulation, correct? So now we are going to familiar with the code. Okay, click on code. If you click on it, you can find something called blocks plus text. Okay, so blocks in the sense in our lower ages, no, we will place something called a puzzles, right? By arranging some cards, we will make the picture complete, right? Such that it is going to have set of rules. Okay, that rules needs to be picked and placed like this. You can arrange it. So this type of programming can be block programming. Okay, it is called block programming. It is much easier for you people, right? You can explore a lot. Okay, what we are going to do is we are going to use only text. We can use both also, blocks plus text. Okay, now we are familiar with the text, so we are going to click on text and it is going to give you certain warning. Continue. Okay, once I click the text now, it is going to give me certain code. This is the basic code. It's just going to blink the onboard LED for about 1 second. Okay, so we have to understand the difference between blink and on. Okay, what do you mean by blink? What do you mean by on? Yes, like a scratch, exactly. Arduino, yes, Arduino can works without connecting with the computer once it is coded. Okay, for programming we have to use, okay, for programming we have to use computer. Once Arduino is programmed, then by providing power supply, it is going to work. The code which we are going to provide is going to be available permanently. Okay, yes. Blink means on and off. Exactly. Blink means on and off. Okay, it is not only one function. It has two functions, right? On, off. Also, we can't able to see the status of the LED if we on and off. Okay, at any one state is going to be visible to us. So what we have to do is we have to introduce something called a delay. We may provide certain observation time. I have to turn on the LED. I need to provide some time for observation, and then again I have to turn off the LED. I must provide some time for observation also. Okay, so there will be two delays, right? So we will discuss about the functions here, digital read, digital write, delay and everything tomorrow. Okay, don't worry about it. We have to see certain output, no? So for that purpose, I'm going to use the same code as it is. Okay, tomorrow we will have discussion about what is pin mode, what is digital write, what is wide setup, what is wide loop, what is the purpose of setup and loop. Everything we will understand tomorrow. Okay, so with the same code, no, I'm going to burn it. How I can burn this code? Simply by start simulation, it is going to be burned. You people can observe in the screen now. I will tell you certain things. Okay, I'm keeping like this. Okay, once I do start simulation, no, this USB cable is connected. Okay, you can observe that, right? And then this on LED is going to glow. First thing, okay. Then this program is going to be burned immediately. Okay, so we can't able to check the TX and RX simulation and all that we will see in live board. Okay, in real board. After that, after programming it, the purpose of this program is to blink the LED. This LED, it is going to be blink for 1 second. That means it is going to on for 1 second, it is going to be off for 1 second, and it is going to be repeated forever until we power off or stop simulation. It is going to work. Okay, so you people can observe. I'm going to start simulation. You see it is connected. Okay, the power indication LED is on with the color of green, correct? And see this, the orange color, it is going to blink for 1 second each. Okay, so we can't able to measure with the help of our stopwatch and all. Okay, it is a being a simulation window, it is going to blink. That's it. It is observable time limit it is going to give us. Okay, is it blinking, pa? Is everything clear until this? Yeah. Okay, right. Okay, done. So now, so LED blink, we have blinked the onboard LED. Okay, so for this blinking, what are the things we must do? How we can make these functions and all that we will discuss in the next class. Okay, so far everything clear, right? Do you people have any doubts? And the purpose of this Arduino board, no, that we will explore more and more in coming days. Okay, where we use this? Yes, exactly. That we will discuss. Okay. By default, will it be set to blink? Yes. By default, the board is available with the blink program. Okay. If you power it up, the LED is going to blink. That is a very basic test code they have provided in the board itself. Okay. Yes. Yeah, we can use it in project. We can use it a lot, Kanna. Okay. In subsequent days, we will see. Make this note this particular question where we use. Okay. I will give you a lot of examples there where we can use such things and all. Okay, if you people have any doubts, you can ask. Yes, otherwise we will share a feedback form in the chat window. You people can post your feedbacks. Okay, Kana, till then, if you have any doubts, you can ask.
Gonna try to learn how to write the LinkedIn post. Tomorrow we will teach. Be ready with a few images. Okay. Once you completed the feedback form, you can leave. And if anyone having a Tinkercad login issue, any other issues, you can stay back and you clarify your doubts. It may be in the fundamental one or the Arduino, anything. Just start sharing your screen. And if you done the feedback, you can leave. C++ using to code. Yes, yes. Parts are taught is a C++ platform only. It is little bit similar to C. Ananya, are you clear? It's a C++ code only. They are closely monitoring. Okay, shall we end the call? Why? Today I will clarify this doubt. Kana, that college opening and all, don't worry. The government holding so many procedures. We will call you. By the time we have so many works to do in the home itself, please do it. Yes. Thank you very much. We are going to end the call. Any doubts? Any doubts? Any difficulties? Recorded session I will try. And how to share I will try. Okay. It's a 2 hours lengthier video. We'll make it in any one forum and we will share. Okay. Yes. Thank you. So shall I end the session?